Did you know that a single unstable atom can damage your DNA, destroy organs, and even take a human life? Today, I'll explain how radioactive decay really works. There are three main types of radioactive decay: alpha decay, beta decay, and gamma decay. Understanding these processes is a core part of nuclear physics and nuclear medicine. My name is Zubair. I'm a nuclear medicine resident, and in this video, I'll explain each type of radioactive decay in the simplest way possible. Alpha decay. Alpha decay occurs when an unstable nucleus emits an alpha particle. An alpha particle is made up of 2 protons and 2 neutrons, which together form a helium nucleus. When alpha decay happens, the atom loses for units from its mass number and to units from its atomic number. Because of this, the original atom changes into a completely different element. Although alpha particles carry a large amount of energy, they are heavy and cannot travel very far. Their penetration power is very low, meaning they can be stopped by a sheet of paper or the outer layer of human skin. Alpha radiation becomes dangerous mainly when alpha-emitting substances are inhaled or ingested. A well-known example is Alexander Litvinenko, who was poisoned with polonium-210, an alpha emitter. Inside the body, alpha radiation causes severe DNA damage and produces highly reactive free radicals. This can lead to a drop in white blood cells, damage to organs such as the liver, kidneys, spleen, and bone marrow, gastrointestinal failure, hair loss, and eventually death. Beta decay. The second type is beta decay, where the nucleus emits beta particles. These particles are high-energy electrons or positrons. Beta particles are much smaller than alpha particles, allowing them to travel farther, but they can still be stopped by clothing or thin aluminum sheets. Their ionizing power is lower than that of alpha particles. Beta decay occurs when a nucleus has an imbalance of protons and neutrons. There are 2 main types of beta decay. Beta plus decay, a proton converts into a neutron, releasing a positron and a neutrino. The atomic number decreases by 1, while the mass number remains unchanged. Beta minus decay, a neutron converts into a proton, releasing an electron and an antineutrino. Gamma decay. The third type is gamma decay. Unlike alpha and beta decay, no particles are released from the nucleus. Instead, excess energy is emitted as gamma-ray photons, a highly energetic form of electromagnetic radiation. Gamma radiation does not change the structure or composition of the atom, but it has extremely high penetration power. It can pass through most materials and requires thick lead or concrete for effective shielding. Because of its penetrating ability, gamma radiation is widely used in medicine, especially in oncology. One example is the gamma knife, which uses focused beams of gamma rays to destroy cancer cells. Gamma rays are also used to sterilize medical equipment and preserve food.